Our mission at Eureka is to ensure that AI deployed in the real world is aligned with human values. And the topic of the talk today, which is contextual red teaming for vision model, plays a big role in how we approach this problem. AI and autonomous systems in general are already operating in the real world. We have seen AI agents making transactions on the web, all the way to the physical world, such as autonomous vehicles that are navigating the cities, there are autonomous taxis, and so on. The quality of the decisions that these autonomous systems make critically depends on the accuracy and quality of their perception systems. So in the case of the web agents, they should be able to sort of distinguish malicious and links that are fine to click on. And in the case of autonomous driving, the perception system needs to understand the contextual scene. They need to detect pedestrians, other vehicles, the traffic signs, buildings, and so on. But the real question is, how can we trust the perception systems of these autonomous vehicles and sort of AI agents? And also more specifically and precisely, how can we measure the robustness of visual AI systems? Before getting into sort of evaluation of robustness of AI systems, let's take a look at our own perception system. So look at the screen for a second. There's a gray bar in the center. Which side of this bar do you think is a darker shade of gray? I'll give you a second. If you're anything like me, the left side is obviously looks lighter than the right side of the bar. But if you look closely, the bar is actually the same shade of gray. So the context, which is in this case the background, matters in how we perceive different objects. And AI systems aren't any different, although the context of use and the way that they perceive context might be different, but context definitely matters in the way that they perceive the world. But are context in general considered in AI evaluation paradigms? Not necessarily. Like a standard way of evaluating these models is through some sort of a static testing. And we look at the average performance. If the average performance fulfills certain requirements, then we push the model to production. But context must be considered in evaluation. And I'm not saying that like context is never considered in evaluation, but the current approach is basically you decide on the relevant context, you go collect data, then annotate and process data, and then finally you go and test the model on that relevant context. In the case of autonomous vehicle, you can think of the weather conditions to be the context, the time of day, the terrain or the environment, like cities, urban environment to sort of rural environment and so on. And then the data is collected, annotated, and processed. But this entire sort of workflow is flawed in the sense that, first of all, you decide on the context before you annotate the data. Sometimes the context may change. Sometimes you may have forgotten to include the context that was really important for that task. The process of data collection is also inherently limited and biased because let's say that you want to collect data for autonomous vehicles, but you're located in like LA. How would you sort of collect data about like snowy weather? It doesn't snow in LA. So what's the approach? There's also counterfactual sort of scenarios that you want to evaluate the model on, or sort of really rare scenarios that are unethical to collect data from. For example, accident scenes. You don't necessarily want to cause an accident to be able to collect the data. That's unethical. And also, as sort of common in the ML community, 80% of sort of the model development pipeline is spent, 80% of the time is spent on sort of annotating and processing the data. So that's a huge time-consuming, tedious process. What we do at Eureka is we eliminate all of these pain points. We provide a way for on-demand contextual red teaming of visual AI. So users can come in, describe their context in an interactive way. For example, in this case, they can say how well the model perform in mountainous terrains. And then the user agent interacts with the user and asks them more questions about, like if they're interested in providing more context, like weather conditions, object of interest, time of day, and so on. And once the user is satisfied with the level of context they provided, the context agent takes that information into the platform, and after a few minutes, the user can explore sort of failure modes of the model in a contextual and an intuitive way. So in this case, the model is sensitive to different sort of lighting conditions, to different weather conditions, and then you as a user would know when and to what extent you can rely on this model. So there's a lot going on in the background that I haven't gone into the details of, but at a very high level, based on the context that the user provides, we take the platform takes that information. It's a multi-agent system. So based on that information, the platform generates synthetic data that is annotated already. So there's no need for human annotation. And then utilizes that sort of synthetic data and test the model on that data and sort of extract the failure modes using vision language models at the end to inform the user on like these type of failure modes. And our sort of services, these type of contextual red teaming is accessible to basically everyone, both developers and non-developers. We are providing API access to the contextual red teaming. And also, as I mentioned, you can directly sort of do the red teaming via the platform. You can just upload the model or provide it through sort of Hugging Face or wherever you want, and provide the context and just see the result without any need for sort of coding. But you may ask, like the red teaming is not necessarily the end. What happens after you find a vulnerability? Naturally, you would like to fix it. So we're not just stopping at automated red teaming, although it's the first step in the process of ensuring the robustness of the visual AI systems. But after the model is evaluated and these common failure modes are understood, what we call the data engine generates relevant data, diverse data for the common failure modes, and then the model is automatically fine-tuned on those relevant contexts that the user provided, and then those sort of vulnerabilities are addressed. So that's overall how we sort of close the loop for going from sort of bringing a model to testing it, to finding its vulnerabilities, and also addressing them. If you are interested in a sort of a more detailed demo, and also if you're a developer and you would like to access our API, please email us at admin@eureka.com. We are also growing our team. We are looking for both machine learning engineers and also software engineers to join our technical team. And you can scan the QR code that takes you to the application link, and you can sort of sign up from there. And we're looking forward to continued conversation. We're looking forward to democratizing the way that AI affects our lives. We want to have a say, and to some extent, we're empowering users to decide whether the AI that is affecting their life is aligned with their values and is robust. Thank you for your attention, and happy to take questions or take the questions offline.
Thanks so much, Kia, for the presentation. I think red teaming is obviously one of the most important things to ensure that generative AI models are safe and secure, especially when it comes to defense and security like applications. Our team at Anote, we've worked with NIST ARIA on a few like red teaming use cases, and